Hey friends, very good evening and thank you for joining in today. Could you please confirm in the chat window if you're able to see my face in this case and also see the and hear my voice clearly or not, so that we can continue with the rest of the things that we want to carry on with. Again, I have, hey folks, thank you very much for joining. Good evening. And yeah, just on time. So could you please confirm in the chat window if everything is working well? Okay, let me also share the screen. So I'm sharing the screen now. Can everybody, anyway, I have the chat window open on a different computer. So can you see the screen? Is everything all right? Okay, so seems like no issues, audio, no glitches, thankfully. Let me just check the audio output also. Yeah, seems like good. Okay, sounds good folks. Okay, we'll get started right away since it's anyway 7 p.m. Let's jump into the discussion. So somebody was asking, I just saw this. Somebody was asking, is this useful for students who are preparing for GATE? Again, GATE questions, there are a lot of recursion. Recursion is a very important problem in data structures algorithms. If you're a student who is preparing for GATE, you will benefit something, but this is primarily for students who are planning to crack software engineering or data science or machine learning roles at product-based companies. That's the key objective here. So it'll benefit you, but not as much as focusing your full time on solving GATE problems. Okay, just wanted to clarify that. Cool. So good. Yes, this session will be recorded. It will be available on YouTube also. Okay. Cool. Sounds good, folks. Thank you very much. And again, as far as GATE live sessions, somebody was asking about GATE live sessions. We have a scholarship exam tomorrow. That's why we did not conduct any live sessions this week. And starting next week, we'll again start the problem solving sessions just like the way we did earlier. And we should be able to finish the second iteration by late December. Anyway, we've just created a schedule. We'll share it with you today, tomorrow. So we didn't conduct this week primarily because we had a scholarship exam for everyone. Okay, cool. Yes, so okay, so this is helpful both for applied AI students and for interview prep students, just to be clear. Okay, so let's get started, dive into the discussion itself. Again, first I'll try to cover a bunch of examples, and so we'll first cover all the notes and examples and all the content that we wanted to cover today in the first about 70 to 90 minutes. Let's see how much time it takes. And then we'll spend about 20 to 30 minutes. I'll answer all the questions that you have in the chat window. So while I'm covering the concepts, I may not be able to answer all the questions in the chat window because it will disturb the flow of the concepts, right? So cool. So this session will be recorded. It will be available on YouTube itself in case you're not able to spend time right now. Okay. So the objective of this session is we will cover a bunch of recursion problems. The focus is not just about recursion, because many of you might already know recursion. The objective here is how do you take real problems that are asked in top product-based companies and how do you build that skill of problem solving? This is the most important skill, right? Because at the end of the day, you can write code in any major language. You can write code in C, C++, Java, Python, doesn't matter, right? Any language you can write it. Most modern programming languages have recursion. The most important skill that is lacking in candidates is not their ability to program, because most people can write recursion program in any of these major programming languages. They are not able to frame the problem and tackle the problem. So we'll focus more on building that problem solving skills and how to do it step by step rather than on explaining what recursion is. Even in the announcement, we clearly mentioned that we expect people to know what recursion is. This will primarily help students in our interview prep course, whose objective is to help students land in software development engineer roles at product-based companies, and also applied AI course students who are preparing for data scientist or machine learning engineer or machine learning scientist roles. Again, these types of good recursion problems are typically asked in product-based companies. So this will benefit both students of applied AI course and interview prep course who are looking to get into product-based companies. Okay, cool. So with that set, again, just wanted to reiterate it. This session's target audience is people who are preparing for software engineer, data scientist, or machine learning engineer or scientist roles in product-based companies. Okay. Again, as for data scientist and machine learning engineer or scientist roles, if you come from computer science background, or if you have prior experience as a software engineer, right? If you already have prior experience as a software engineer, or you come from computer science background, and if you interview at product-based companies, you're expected to encounter some of these recursion problems. Software engineers at product-based companies, there is 100% likelihood that you will encounter some problem like this. So people from computer science or software engineering, data science and machine learning, data scientist or machine learning engineer roles, there is almost like a 80% chance that you will encounter questions in this. In non-product based companies, you may not encounter these questions. Okay. I hope this answers some of the questions on who is the target audience for this. Now, simply speaking, again, recursion is a very fundamental concept in computer science. Okay. So again, straightforward recursion can solve a bunch of problems. Again, those of you from interview prep course or computer science background, you all might know about dynamic programming. Again, some of you who are from non-computer science background may not know it. But dynamic programming at its very core is nothing but recursion plus memoization. Again, this is a concept that we discussed in deep learning. Again, for those of you who are from the AI course, in deep learning, your backpropagation algorithm, your whole backpropagation algorithm is nothing but uses memoization and dynamic programming internally. Similarly, recursion is also used in a lot of backtracking like problems. So a lot of times dynamic programming is extensively asked in top product based companies. And while solving dynamic programming, again, this is for software engineering roles. For software development engineer roles, dynamic programming based problems are very commonly asked. And for dynamic programming problems, the hardest part is to arrive at the recursion. Because once you arrive at the recursion, doing the memoization or bottom up is very straightforward, right? If you're looking for data science or machine learning roles, you may not be asked dynamic programming, but you'll be asked straightforward recursion problems. So in this session, we'll focus on straightforward recursion problems, not so much on dynamic programming and other approaches. We'll probably conduct another session in the future just on dynamic programming, right? So again, that's the agenda. So what is the focus of this session? The focus of this session is to build that problem solving skills, how to solve recursion problem. It is not about code, because I'm assuming most of you know some programming language, some modern programming language like Java or Python, right? I'm assuming you all have done your n factorial problem, your Fibonacci, all these basic simple examples. I'm assuming you know this basic recursion. So we will actually take problems which are asked in top product based companies, and I want to explain you how to think from a solution perspective, how to solve. Right? Again, some of our students who are in the interview prep course might have seen many examples like this, right? So we have almost 200 plus solved problems where we explain step by step on how to think about the solution and how to write the solution itself. Again, all the code that I'll try to present here will be like a pseudo code. The reason being, I understand some of you program in Python, some of you might program in Java, some of you program in C, C++. So the reason I'm going to show you pseudo code is you can translate this code, because our objective here is to build the problem solving skill, not the final code itself, right? There are tons of other resources. If you just want a code snippet, there are hundreds of resources on the internet. What is most important is how do you build that problem solving skill? How do you build that core? This is the most important thing. This is the most important thing, because I remember when I was interviewing with Yahoo Labs many years ago for a machine learning engineer role, I coded everything in C and they were perfectly all right, right? What is more important is your ability to solve problems, because programming languages come and go and you can pick any of the major programming languages for most product-based companies. Cool? So the idea here is this. Whenever you're solving a recursion problem, always think about it from this perspective. It's a very simple concept. First, write down various cases for the given problem. First, understand the problem, obviously. Write down various cases. Again, a lot of people don't do due diligence here. Okay, I'll show you some examples anyway. Once you write various cases, you can easily arrive at the recursive case in any recursion problem. Whenever you're solving a recursion problem, there are two things that you have to handle. You have to handle what is the recursive case, what is the boundary case. This is where most people get stuck when they're solving recursion problems. Okay, so we'll take a bunch of examples. The easiest way to arrive at recursion case is to solve a lot of recursion problems, obviously, but also write various cases. I'll show you some examples here. So there are three steps, broadly speaking. One is write down various cases where n equals to 1, n equals to 2n equals to 3, so on and so forth, and arrive at the recursive case, then think of the boundary case, then write the function implementation. Actually, function implementation is straightforward if you have both of these figured out, right? Again, let's solve some 2-3 problems today, and I'll follow these 3 steps. First, I'll understand the problem. I'll look at multiple examples, try to solve it manually on pen and paper. Using that, build the recursive case, then also arrive at the boundary case. Then I'll write pseudocode for function implementation. Okay, I hope this will get it right. Cool. So this is a very, very common problem. Okay, it's a very common problem. I mean, it's very much asked in almost all the major product-based companies. The question is this: some of you may have forgotten this. This is a photograph of a number pad in a feature phone, right? Those old Nokia phones. I think there are also some Nokia phones now, right? This is a feature phone, right? So if you notice, so some of you who are youngsters may not know about this, right? So let's understand the problem. Imagine if somebody presses the key 2 and presses the key 6. Okay, whenever if you press 2 and 6, suppose somebody press 2 and 6, okay, it could correspond to strings AM, because there is A here, there is M here. It could correspond to, okay, so look at this. 2 corresponds to characters A, B, C. 6 corresponds to characters M and O. Similarly, 9 corresponds to W, X, Y, Z. 7 corresponds to P, Q, R, S, and so on and so forth. 1 does not correspond to any character. 0 does not correspond to any character. Suppose if somebody gives you a numeric value like 26. Imagine somebody gives you 26. This is your input. The output you should generate here is corresponding to 2. What all characters are there? A, B, C. Right? Similarly, corresponding to 6. What all characters are there? M, N, O. So I want to output strings like this. The first character are characters corresponding to 2. Right? The first character is characters corresponding to 2. The second character is characters corresponding to 6. So look at this. AM is one such string because I'm taking A from 2, M from 6. Similarly, BN is another string because I'm taking B from 2, N from 6. Right? I hope this is clear, right? So the objective is very simple. Given this sort of mapping, the 2 corresponds to ABC, 3 corresponds to DEF, so on and so forth, 9 corresponds to WXYZ. If your inputs is a number like this, which consists of digits only from 2 to 9, it does not consist of strings, digits starting from 1 and 0. Let's assume it does not have that. It only has digits from 2 to 9, right? Now you should output all the possible strings like this. That's the question. Again, it's a very simple question, very, very easy way of doing the question. Okay, again, this is not exactly your typing on a Nokia phone. That's a different beast altogether. This is a much more simplified version of the problem. Okay, this type of problem, again, we have had some of our students who interviewed at top product-based companies. For machine learning engineer roles, these questions have been asked because this is a simple recursion problem, right? Similarly, for software development engineers at top product-based companies, you can easily expect a question like this. Very often in phone screen itself, right? Because it's a simple problem. It's not a very hard problem, right? So when you have a problem like this, first understand the problem. No doubts about it. I hope you understood what the problem context here is. Now, given the problem context here, how do you now tackle it? The first thing that you should do here is work out examples. So always work out multiple examples. Earlier, I mean, imagine if you're just getting started with practicing programming, do at least 2 to 3 examples. For example, imagine you have 2, 6, 9. Okay, imagine you have 2, 6, 9. 2 can correspond to characters A, B, C. Then whatever, see, 6 will correspond to a bunch of characters. 9 will correspond to a bunch of characters. Now you have to pick A, map it to this character. So all the possible combinations you need to output, right? That's the whole idea, right? You need to output all the possible combinations. That's the whole idea that we have here, right? So again, I strongly recommend that whenever you're solving a problem like this, imagine you have 2, 6, 9, work it out. Work out examples by hand on pen and paper. Lot of people don't do a good job at it. Again, some people do just one case and they say, hey, I got the answer. Don't do that. Especially if you're a beginner in the early days, try and do multiple examples. 361. Okay. Sorry, one can't be there, right? So 360, let's say 364. Okay. Similarly, take an example with only, let's say 2. Just I mean, take multiple examples. This is a 3-digit number. This is a 1-digit number, right? Think of other cases also. Think of something like 5-digit number. Okay. So let's assume 27564. Try to work out how to do it manually. Lot of times people don't do it. Okay. Because once you do it, our human brain is so good at detecting patterns. Okay, we are really, really good at detecting patterns that if you do it for 3-4 examples, you will detect the pattern that is there in this. Always keep recursion in your mind. When you're thinking of trying to find the pattern, think of recursion. Recursion basically means given a problem, given a larger problem, break it down into smaller problems in a recursive fashion. Right? Very simple logic. Given a larger problem, break it down into smaller problems of the same type. Again, this problem can be solved even without recursion. Okay, lot of recursion problems, you can solve it without recursion by using a stack and iterative algorithms. But let's first think recursively, because recursion is an easy construct to get to. Lot of people don't do this practice, right? The moment you do some practice, you'll quickly realize that there's a very simple observation. Please do that. Lot of people, they don't do this. I mean, I've seen a lot of beginners who don't do this. The moment you do this, you'll start seeing patterns. For example, let's take this string 269. Okay, this is a string of length what? It's a string of 3 digits. Okay, think of it like a string of 3 digits. So you have a problem which has 3 digits. Now corresponding to 2, I know that I can have A, B or C, right? Imagine if I have strings, imagine I want to break a problem of size 3 into problems of smaller size, right? This 269, this is 2 digits now. Right? Imagine if I have strings S1, S2, so on, so forth, some SK, a bunch of strings corresponding to 69. Now, if I just add, if I already have this, imagine if I have a solution to the problem when I have 69. Imagine I have a solution for the 69. Imagine I already have it, let's assume, right? Which means I have the length of my string here, or the length of the input here is 2 digits. If I have this, corresponding to 2, I know that there are ABC characters. I can now concatenate A with S1, A with S2, A with SK. Similarly, I can concatenate B with S1, B with S2, B with SK. Similarly, I can concatenate C with S1, C with S2, C with SK. Right? And if I just concatenate an output, I am done. Right? So now look at this. Again, whenever you're writing example, whenever you're trying to solve these examples by hand on a piece of paper, keep the recursion in mind. Because sometimes the recursion is not that trivial. This case is one of the simplest examples. I'll come to slightly more complex examples just in a few minutes. This is one of the simplest examples. My suggestion as a rule of thumb, especially if you're a beginner, my suggestion is this. Do as many examples as you need by hand. Sometimes you might have to do 3 examples. If it's a complex recursion, you might even have to do 10 examples. That's okay as a beginner. Do as many examples as possible to arrive at the recursive formulation easily. Lot of people don't do that, and that's very, very important. Okay, this is exactly what I just told you a while ago, right? Which is, imagine you have 269. 2 corresponds to these characters ABC, right? I have an input of size 3. If I can get strings S1 to SK corresponding to 69, which is basically an input of size 2, I can do it, right? So it's arriving at the recursive case is very easy if you look at examples. Do as many examples as you need, because the most important aspect of solving recursion problems or dynamic programming problems is to arrive at the recursive case. You get this boundary case or base case is very easy to arrive at. Okay, so the logic here is this. If the length of the input is greater than 1, then we will get some recursion. Again, I'm just writing some simple English-like text here, right? Always use examples. Please don't think lowly of them. Next, what is the base case? Very simple. If length of input equals to 0, suppose you have, let's assume your input is 269, right? Suppose you have all the strings for the whole 269, you have all the strings, right? You don't have, so this is your input, you don't have anything left. If the length of the input is 0, we are done. Just print all the words that you have and return, right? Very simple base case or boundary case. Again, I'm starting with a simpler example. We'll go to more complex examples one by one. This is, so by lot of product company standards, this will be somewhat between easy to medium. okay, by lot of product company, especially for software development engineer roles. For machine learning or data science roles, this is considered medium to hard. Medium actually, not even hard, right? Because the expectation from software development engineers in terms of programming ability is more. So we are starting with a simple, again, the recursion here is very easy to arrive at. Again, there is a non-recursive solution also. I'm not denying that. You can build a non-recursive solution in this case. You can build a simple iterative case also. One thing that you can always do, another very important strategy that a lot of people don't do is mapping. So if you think of this, this problem looks like combinations and permutations, you know. See, when you're practicing, try to practice as many problems as possible. This problem looks like a combinatorics problem of doing permutations and combinations. Again, in our previous sessions where we discussed about again, in our previous sessions about Python programming, we have shown how to generate combinations and permutations of strings, right? So this is sort of like combinations and permutations, but with slight difference that whenever you have 2, you can only use ABC. Whenever you have 6, you can only use MNO. Whenever you have 9, you can use WXYZ, right? It's a slight modification to that problem, right? So you have the base. So first thing, understand the problem. Second, work out examples to arrive at recursive case. Understand the base case. Then start building all the data structures that you need and start solving it. Okay, very simple. Again, I'm doing a lot of, the objective here is not to solve the problem perfectly, but to teach the problem solving mindset. Okay, so here is some quick English like pseudocode. So imagine again, this is like a list, or you can for C programmers you can think of it like a 2D array. Okay, so corresponding to 0, again this hash basically means it's a comment in Python. Okay, so this corresponds to index 0, this corresponds to index 1, this corresponds to index 2, so on and so forth. This corresponds to index 9. So you have this 2D array or a list of lists if you're thinking about it in terms of Python, where you have all the characters corresponding to each numeric value. We are storing a mapping. Again, you can also store this in a dict if you're using Python, or a hash map if you're using Java. You can use any of these data structures. Okay, you can store this in a dictionary, you can store this in a 2D array. That's why I'm not going specifically into programming specific stuff, because all programming, like for example, C does not have a dict inbuilt, right, or a hash map inbuilt. That's why I'm doing pseudocode. People who are using, who want to use C++, please consider using STL, right, because STL has some of the major data structures and algorithms already implemented for you. Okay, people who are using Java, Python, most of these things are readily available. So this K is basically a mapping, right? It basically says corresponding to 2, what all characters are there, corresponding to 9, what all characters are there, and so on and so forth. First, this is a basic data structure which we'll use. Next, look at this. Now I got the recursive equation. Let's think of what all things do I need. I need K. Okay, I need to store all the results, right? So you can store the results as a set of words, right? You can store your result as a set of words, okay, or a list of words if you want to use lists. Again, that data structure you can change and it will still work perfectly all right. Again, some programming languages have a data structure set inbuilt, some programming languages don't have it. That's why I'm leaving it open-ended, because the implementation might change slightly from programming language to programming language. Now, our function could look like this. So you have this function called print words, right, with some input. This input will contain, let's say, 269. Okay, this is where your input is. Now, given this input, you want to now print, you want to have all the words that are generated in this global variable called result. Again, there are multiple design choices. You can pass K and result also as parameters to this recursive function. Our recursive function, let's call it print words. Okay, or you can keep them as global variables and keep appending to them. There are a lot of those design choices that you can play around with. Okay, I'm just discussing one such possibility. Again, I'm not saying this is the best implementation or this is the only implementation, because the focus, as I was mentioning earlier, the focus here is not the exact final code, but how to think about solving. Because the problem solving thing is what is often lacking in many candidates that we work with, that we interview and things like that. Okay, cool. So let's look at, so now what do we have? We have some function that we want to, this is how we want the function to be there. These are the data structures that we want to use. And we have the base case, we have the recursive case. Let's try to translate this into code. Again, this is a very crude pseudocode. A lot of implementation details have been skipped because we want to focus on problem solving. Okay, you can, again, as an exercise, you can implement each of these in the programming language of your choice. Okay, so first and foremost, let's handle the boundary case. So this is your boundary case, right? This is our boundary case. Okay, what is our boundary case here? If length of input equals to 0, print result and return. Boundary case, very simple. Else, this is your recursive case now. Okay, again, this problem is one of the simpler problems. Okay, so whenever you're writing code, one other very important thing that you should do here is take some inputs first and write your code working out an example. Okay, suppose this is your input, right? Suppose your input is 26. Okay, so I will create variables and I'll write code. While I'm doing it, I'm doing a dry run here. This is what is called as a dry run. Again, lot of students that I see, they try to directly jump into the code. Always try to write it on a piece of paper. Like even today, when I have to implement some code, I try to write at least the high level logic on a piece of paper because I can do the dry run here. So imagine if the input is 26. Again, these are simple steps that a lot of students skip, making mistakes. Especially if you're a beginner, even if you're an intermediate level programmer or even an advanced programmer, this is a better way to think of it. Lot of people criticize whiteboard programming in interviews, but what the whiteboard programmer, what the interviewer is trying to look at is the high level logic. He wants to get at the high level logic. Then you can go ahead and implement it in any programming language of your choice. Okay, because this is one way to understand what is happening. Okay, so let's go here. So let's assume our input is 26. First we want to take character 2. Okay, so I'll just say input 0. I'm just indexing the input. Let's assume, again, the way you store it, if you store it as a numerical value, then you'll have to do it slightly differently. If you store it as a list or as an array, you can, I'm just using some generic notation here. Okay, first let's get the pseudocode right, then you can translate it into any programming language fairly easily based on the programming language specifics. So you have 26, so your x becomes 2 now. I'm doing a dry run as we go. Then I'm saying, get me all the characters, chars kx, so k2. Okay, so what is k? Again, remember the k is nothing but our matrix here. K is this matrix, or k is this data structure that we have here. K2 will give me ABC. So I'm getting all the characters that are corresponding to 2. Okay, so your chars become ABC, right? Again, let's go step by step here. Let's go step by step. Next, what do we want to do? So we already have in our chars, we have A, B, C. Now what do we want to do? For each of these characters, we want to append this character A. We want to append this character A in front of each string SI. This SI itself is generated by getting words of length. And so suppose you have an input, right? Your input is, let's say, 269. Okay, corresponding to this 2, you got A. Now we want to get all the words corresponding to 69, right? So this SI will be words that correspond to 69. And then you want to concatenate it before you want to so you want to do A plus, basically sometimes uses a concatenation symbol in programming languages like Python. So you want to concatenate A before SI and print everything. But you want to do this for A, you also want to do this for B, you also want to do this for C. Because you want to do it for 3 things, you need to have a for loop. Again, always write this logic right next to your code. That helps you immensely, especially at a beginner level. So for each C in characters, what do we want to do? For each C, look at this. Whatever word is there in the result. Okay. So for each C, what do we want to do now? Okay. So I think there is a small hiccup here. Okay. First, what we want is, we want to run this. Okay. Sorry. There is a small error here in the code. Again, look at this. By going line by line, we can fix it better. Okay. So this line has to go above. Okay. This line has to go here. Okay, for each character, so look at this. First, what do we want? First, we want all, look at this. First, we want all the words with input from first string. If you have 269, this is index 0, this is index 1, this is index 2, right? First, we want all these to be generated. Look at this. For all of the words that are there, for all of the words that can be generated from 61, right? Which is nothing but your SI. You want them first to be generated. Right? And you want to generate them and store it into your result first. Okay. So you can call this print words function first. You call this function first. Now, when you call this function, what happens? All of your SI are generated. Right? All of your SI are generated, right? Now, if all of your SI is generated, then all you have to do here is for each SI, for each word, in result, which means for each SI in the result, you concatenate this character now. You concatenate this character with the word and you're done. Right? So again, very, very importantly, what you have to do is you have to go step by step and write this iterative loop. Okay. So again, in this case, so this is a fairly simple problem. This is not a rocket science problem. This is fairly simple problem if you think about it. Okay. Fairly simple recursion problem. Now, okay. Oh, I already jumped into it. Anyway, let me explain this since we anyway jumped into it. So once you have, again, please implement this on your own. So please try to implement this code on your own in the programming language of your choice. Now let's jump into, so 1 second. Okay. Again, folks, I'm just looking at, just 1 second. Okay. Okay. So what is the time complexity of this code? Okay. First of all, before we go into time complexity, again, time complexity is another thing that a lot of people mess up. But let's think from first principles, no? Suppose imagine you have an input string of length n. Okay, let's assume you have an input string. Okay, or in other words, let's assume you have an input string. Okay, so let's assume, let's put it slightly differently, no? So let's assume you have 269. Okay, just for simplicity. Let's assume you have n words because 2 maps to only 3 characters, while 9 maps to 4 characters, right? So some of them map to 3 characters, some of them map to 4 characters. For example, if you look at 7, okay, if you go and look at this example, right? So if you go and look at this example here, so 7 also maps to 4 characters, 9 maps to 4 characters, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6 and 8 map to only 3 characters, right? So if you want to get a very nice bound on it, let's assume n is the number of characters, number of digits. Okay, number of digits that map to 3 characters. Okay, and let's assume m is the number of digits that map to 4 characters. Okay, that map to 4 characters. Okay, let's assume. Now forget about our code for a second. Just forget about our code for a second. Okay, let's assume this is the setup. Okay. So you have some, suppose you have some digits. Let's assume n is the number of digits. So for example, let's assume you have 2, 6, 9, 7. Then your n is 2 because you have 2 digits here that map to 3 characters and m is also equals to 2. Okay, because you have 2 characters here or 2 digits here that map to 4 characters, right? Now this 2 will correspond to 3 possibilities. This 6 will correspond to 3 possibilities. This 9 will correspond to 4 possibilities. This 7 will correspond to 4 possibilities. So what is the total number of strings? This is a straightforward counting problem. The total number of strings that you will get is 3 cross 3 cross 4 cross 4, which in other words is nothing but 3 power n into 4 power m. Right? If you think about it, it is 3 power n into 4 power m, right? Very simple. And if you think about our code has to print all of these 3 power n into 4 power m strings. It has to anyway print all of this, right? It has to print all of this, which means the time complexity of our code is going to be exponential, right? Again, in lot of programming interviews, you just have to get the approximate complexity properly. Very often, you don't have to get 3 power n into 4 power m. Okay, you don't have to exactly get this. Even if you just say it's exponential time complexity, people understand it because people understand that you have order of 1. You have log n. These are the big ones, no? Order of n log n, order of n square, or n power p. Not so much. This is something that we don't encounter as much. You sometimes encounter n cube, or you have exponential time complexity. Again, there are other time complexities also. But if you just say this is logarithmic time complexity or linear time complexity or n log n or polynomial time or exponential, people agree with that. Okay, because we know exponential is fairly bad. You don't exactly have to get the values, right? So in a lot of product-based companies, even if you just say this is exponential time complexity, because look at the output. The number of strings that we have to generate is exponential in the size of the input. What is the size of your input? Your size of input is n plus m, right? Right? So this whole thing can be written as order of, if you just use order notation, you can write it as order of n plus m. right? Or, I mean, you don't have to even get into this exact specifics. You can just say this is exponential time complexity and you're good to go, right? So again, space complexity is also the same thing, right? Because you have, again, some of you who are from our AI course may not know about recursion stack, etc. Right? So there is something called a concept of recursion stack, especially when you have to compute time space complexities of recursion problems. But the space complexity here is also, again, those of you who are from our interview prep course or gate course know about how to compute space complexities, right? So using the recursion stack. So in this problem, again, this is a very, very common problem that's asked in phone screens for software engineers or even on-site interviews for data science folks. This problem is not hard. It's a fairly simple recursion problem and you can figure out this recursion by examples. That's the most important part here. Okay. So, I mean, this is the most important thing here. Okay. Again, I hope the complexity part, right? The simplest way to think about complexity is look at the number of strings that we have to generate. Somebody is asking about the time complexity part. Again, I think, again, this video will be available on YouTube for you to watch later also. The simplest way to think about is look at the, if my input string has, let's say, these k characters, okay, n plus m characters, right? In each place, I will either have 3 possibilities or 4 possibilities. Okay, so list down all the strings. So it will be 3 into 3 into 4 into 4, right? Simple combinatorics that you probably learned in your 10th class, right? Simple counting, right? Very simple counting. Okay. Again, space and time complexity need not always be the same. Not always the same. As somebody is asking that question, it need not always be the same. Okay. Okay, so let's go to the second problem, which is slightly more interesting. Okay, slightly more challenging and more interesting. It's a very common problem that I've been seeing for the last 1 year or so. Okay, very interesting problem or some variation of this problem. This question is asked at Google, at Amazon, Facebook, you name it, especially for software development engineers. Not so much for data science and machine learning folks because this is slightly on the harder side. Slightly, it's not hard actually. Okay, again, when I say hard problem or slightly hard problem in recursion, the hardest part is often arriving at the recursive part. The moment you arrive at the recursive part, if you are decent at programming, you can construct rest of the pieces. So the problem solving part in any recursion problem is to arrive at the recursive part carefully. I cannot emphasize this enough. So in this example, again, this problem or some variation of this problem has been asked in interviews at Google, Amazon, Facebook, you name it. Both in India, Mountain View, you name it. Okay. So the question is very interesting. Okay. Some variation has been asked. So a strobogrammatic number. Okay. Very tongue twisting name. So let's just call it S number. Okay. An S number is a number where, suppose you take number 0. Suppose if you rotate it by 180 degrees. Okay. You know what is rotating by 180 degrees, right? So if you rotate it by 180 degrees, if you rotate this number by 180. So suppose if you have 8. If you rotate it by 90 degrees, what happens? It becomes like this. This is 90 degrees. If you rotate it again by 90 degrees, what happens? You get 8 again, right? So a number is said to be a strobogrammatic number or an S number if you have this number and if you rotate it by 180 degrees, the same number you will arrive at. For example, let's look at some examples. 0. You rotate 0 by 180 degrees, you get 0. Rotate 1. By 90 degrees, if you rotate, what do you get? You get a horizontal line. You rotate it again by 90 degrees, you get a vertical line. 8. I just showed you, right? 8 also, if you rotate by 180 degrees, you'll get 8 only. So these are the 3 single-digited numbers which are strobogrammatic. Now let's look at 2-digited numbers. If you look at all these 2-digited numbers here, these are all 2-digited numbers that are that are S numbers. Let's just call it S numbers. Okay. So 1 1. If you rotate 1 1 by 90 degrees, what do you get? You get this. Again, you rotate it by 90 degrees, what do you get? You get this. Right? Similarly, 69. Try to rotate it. Rotate it by 90 degrees and again rotate it by 90 degrees, you'll get 69. Again, the 9 has to be written like this to be careful. Okay. So again, it will look like 69 if you do this. Okay. Let's assume the 9 is written like this. The 6 is written like this. Similarly, here also the 9 is written like this. The 6 is written like this. So the 2-digited strobogrammatic numbers are 11, 69, 88, 96. But imagine if you have 2 zeros also, that also looks like a strobogrammatic number. Okay, so this is also another 2-digited number. Again, If you think about it as a number, this is equal to 0. But if you look at it as a 2-digit number, 0, 0 is also a 2-digit number, right? But of course, numerically, it's equal to 0, right? So these are the examples. Now, the question here is very, very interesting. The question here is very, very simple. Again, folks, I will try to answer most of your questions in the last 20 to 30 minutes. Just in the interest of time, I wanted to cover about 2-3 problems, and then I'll surely spend 20-30 minutes answering all of your questions. Okay. Now, here comes the question. It's a very good question. The question here is print all S numbers of n digits. So your input here is n. Your input here is n. Right? Suppose somebody tells you n equals to 10. Print all the strobogrammatic numbers of length 10, of 10 digits, That's what I mean. Again, the reason I said this is slightly hard, actually I will call it medium to hard. I won't even call it hard. Okay. Especially for software development engineer roles, this problem is considered medium to hard. For data science and machine learning engineer roles, this problem is typically considered hard. Okay, again, remember that for most data science and machine learning engineer roles, the bar of software engineering is not as much as a software engineer role. Okay, that's why I'm saying, again, this is not a hard problem. If you have solved any problem like this, it is easy. This is a classic example where you have to look at examples. When I was solving this problem the very first time, okay, when I was personally solving this the first time, I actually went through multiple examples. I had to figure out, again, the hardest part here is to figure out the recursive equation. Because once you get the recursive equation, everything is trivial. There is a slight trickiness here with base case also. You have to get the base case and recursive case carefully. So I almost worked out. So n equals to 1, this is the answer. N equals to 2, this is the answer. So I worked out n equals to 3, n equals to 4, n equals to 5. I even worked out n equals to 6 partially when I was solving this problem myself. Okay, I almost worked out even n equals to 6 because I was not getting the logic perfectly. So what I typically do is I try to work out, this is how I solve it personally. Okay, and this is a good strategy that I see a lot of people use. Okay, write examples for all of them and find patterns in this. That's how, again, suppose, okay, one more very important thing here is, let's assume you're coming up with some pattern with n equals to 3. That pattern might break if you're using n equals to 5. When a pattern breaks, try to come up with a better pattern for the recursive part. Okay. So the first thing, again, whenever you encounter this types of problems, I've not seen this problem being asked maybe 3-4 years back. This is a more recent type of problems that I see companies asking. These are not hard problems. Okay. These require the thought process of coming up with the recursion carefully. Okay. I think this problem, I've seen people ask this in Google, Amazon, Facebook in the last 1.5 years. Okay, cool. Let's write down. Okay. Let's think of all the cases, no? So let's assume n equals to 0. If n equals to 0, what do you have? Okay. So 1 second. Did I miss any case here? 0, 1, 8. So if you have 6, 1 second. So if you have 6, what happens? If you rotate 6 by 90 by... Oh, so 6 is not, somebody is asking in the chat window, isn't 6 a strobogrammatic number? No, because if you rotate 6 by 90 degrees, right, or 180 degrees, let's assume you rotate it by 180 degrees, you get 9. And 6 and 9 are not the same. So look at this, a strobogrammatic number is, if you rotate it by 180 degrees, you should get the same number, not a valid number. That's not the question. Okay, so 6 is not a strobogrammatic number. Okay. So somebody is asking, what is a base case? Okay, let me try to answer that question before we jump in, because that person will be blocked. Suppose you are finding n factorial, right? When you're solving n factorial using recursion, n factorial is, how do you write it mathematically? It is n into n minus 1 factorial. Okay, this is often called as the recursive case. Okay, again, a lot of people learn recursion from Fibonacci numbers or from recursion. That's why I'm giving this example. But till where do you keep recursing? Suppose if n equals to 5, okay, you write 5 factorial as 5 into 4 factorial. You write 4 factorial as 4 into 3 factorial. You write 3 factorial as 3 into 2 factorial. You write 2 factorial as 2 into 1 factorial. Right? Till where do you go? The base case is the case where the recursion stops. Okay, in the code, it is that case where you return the recursion. Okay, so we just say it is equal to 1 if n equals to 1 or 0. Very simple, because 0 factorial is also equals to 1. So this is called the base case of this recursion for n factorial. Okay, those of you who may not know what is base case. Okay, base case is called is also the boundary case of recursion, where you terminate the recursion. Okay, so let's tackle this problem step by step now. Okay, let's assume we have n equals to 0. If n equals to 0, there is I mean no digits, no, so there is nothing left here, so empty. You have to handle this boundary case in your code also. Try to, because somebody gives you n equals to 0, you should handle it, right? If n equals to 1, we know the 3 digits, 0, 1, 8, we already know it. If n equals to 2, we know that it is 1, 1, 6, 9, 8, 8, 9, 6, 0, 0. These two cases we got it. Now, okay, you want to construct n equals to 3. First thing that lot of people try to do is very logical. You try to solve n equals to 3 using other n's, okay, so less than n, okay, less than 3. So you can use n equals to 2 or n equals to 1 or n equals to 0. Again, recursion doesn't always mean, for example, look at Fibonacci, right? Your Fibonacci of n, the recursion case is, it's a recursion of Fibonacci of n minus 1 plus Fibonacci of n minus 2, right? It is recursive on two so problem of size n is broken into two problems of size n minus 1 and n minus 2. Okay, that's the important part here. So sometimes don't always think that a problem of size n only gets broken up into one subproblem. It can get broken down into multiple subproblems also very often, right? That's very, very important to think of. Now, when you're solving this problem, okay, so let's try to solve it. Again, when I solved it the first time with n equals to 3, I tried to use both n equals to 2 and n equals to 1, because I don't know what solution will work. So let's start. Okay, for n equals to 1, we have this 0, 1, 8. For n equals to 2, you have 1, 1, 6, 9, 8, 8, 9, 6, 0, 0. Okay, so let's solve n equals to 3. So if I want 3-digit numbers, I can take, let's assume I take this number. This is how I think. Okay, I'm just trying to share my thought process so that you can benefit from it. So I have 1, 1. From this, I want to create, this is a 2-digit number. I want to create a 3-digit number. Now, I know this 0, 1, 8 solves the problem. So I can say, what if I add 0 here? Okay, so if I rotate this, what happens? By 180 degrees, I get 0, 1, 1. It's not working out because 110 is not equals to 0, 1, 1. So by adding this 0 after 1, 1, it's not working out. Okay, so I rule out that option. Next, I have 1, 1. I understand that if I have 1, 1 and if I rotate it, if I place something in between here, suppose if I place this 0 here, if I place this 0 here in between, instead of placing it at the end or at the beginning, if I place it in the middle, then what can I do? Now see what's happening. This one, when I rotate it by 180 degrees, it becomes 1. This one will remain 1. This 0 will remain 0. Hey, it's working out now, right? So to construct n equals to 3, what if I take all of the n equals to 2's and plug in this 0 in between, this 1 in between, this 8 in between. Similarly, this 0 in between, 1 in between, 8 in between. Again, I don't know how this will work. Let's try it out. Okay, so that's what I've done here. 1, 1. In between, I plugged in 0. 1, 1, I plugged in 1. 1, 1, I plugged in 8. So everything corresponding to 1, 1, I got it here, these three. Next, I took 69. So I take 69, I plug 0 in between, I plug 1 in between, I plug 8 in between. I got all three. Very good. Okay, similarly 88, similarly 96, similarly 0, 0, 0. Now the first thing that you should always think of is there any other 3-digit number that we are missing out? Sometimes this is the tricky part, because you might miss out some cases. It looks like we got all of them. Okay, it looks like I can't think of any case that I missed out. Okay, so what am I doing here? To solve a problem of n equals to 3, I'm using n equals to 2 and I'm using 0, 1, 8 and placing them in between, right? Because I already have a 2-digit number. By just adding this 1-digit number, which is a strobogrammatic number, I can get a 3-digit number. So by again placing it in between is the important idea, right? So this is working very good. Again, I'm telling you how I solved it the very first time, right? Then I said, okay, this seems logical, but will it work for n equals to 4? The moment you try to do it for n equals to 4, okay, let's take n equals to 4. Let's take a 3-digit number. Let's take 101. Now here comes the best part. Okay, suppose if I try to place this 0, where will I place this 0 now? So take all the 3-digit numbers. So you have 101, 111, all these are 3-digit numbers, right? So all these are your 3-digit numbers that you have. Okay. So now let's assume I want to place this 0. I want to take this one. So because from 3-digit number, by adding one more digit, I can get a 4-digit number, right? Now I try to add this 0. Now where will I add? This is odd number of digits, no? So there is no concept of middle. Let's assume I add it here. Oh, it's working in this case because 1001, if I rotate it, it's working perfectly. But if I add it here, this is not working because this is 1011. If I rotate it, I get 1101. It's not working out. So placing it here is not working out. If I place it here, in this case, it's working out, but in this case, it's not working out. So first thing that you have to realize here is what worked for n equals to 3 is not working for n equals to 4. Wow. Okay. So there are two options. One option is probably you have got the incorrect logic, or probably let's think of n equals to 4. How do you construct n equals to 4 by hand? In recursion, doing these things by hand is very, 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 very important. Okay. So now if you try to do it for 4 digits, okay, I say for 4 digits because you should always keep that open mind. Don't limit yourself when you're solving a problem of size n. Don't just go to problem of size n minus 1. Always be ready to go to problems of smaller sizes, right? So now I said, okay, for n equals to 4, using n equals to 3 is not working out. What if I use n equals to 2? Which means I'm going minus 2 here. Given a problem of size n, I'm going to a problem of size n minus 2 now. Okay, now I say, okay, how do I construct strings of length 4? Okay, let's get all the 2-digit strings. We have 1, 1. Okay, let's take 1, 1 and so on and so forth, right? In between, if I plug in, look at this, all these are the other 2-digit numbers I have, no? So if I have a solution, if I have valid numbers of size n minus 2, and in the middle part, because if n is even, look at this, if n is even, n minus 2 is also even. Logically, right? When I have even number, I can break it up into 2 logical parts. I can break it up into 2 halves. And in between, if I stuff my 1169880096, will it work? Let's try it out. Seems like a logical idea, right? So what I'm doing here is, if n equals to 3, I'm using n equals to 2. Or in other words, I'm using n minus 1 and I'm using 018, right? When I have n equals to 4, the same strategy is not working out. So what I'm going to do now is I'm going to use n minus 2 and all the 2-digit strings. Okay, let's see. Let's take examples, right? For n equals to 2, what do we have? We have something like 69. In this 69, okay, let me write 9 here. Okay. Can I plug in something in between? Imagine if I plug in 88, what happens? If I plug in 88, what happens? If I rotate it by 180 degrees, 6886, I get 6889, I'm sorry. This 6 becomes 9, no? So this 6 becomes 9. Okay. 6889. Wow, it seems to work. So I try it for multiple cases. In all cases, it seems to work perfectly. Now I'm not convinced yet. Okay. Now I want to go for n equals to 5. So as I told you, when I was solving this problem the first time, I went to n equals to 6. So now I get a logic now, which is when the number is odd, look at this, when the number is odd, I can just go to n minus 1 and use these 018. That's a logic, that's a pattern that I'm recognizing. But I'm not sure whether that will work or not. When the number is even, like n equals to even, because even numbers, I can break it up into 2 halves, right? I am solving a problem of size n minus 2 and in between I'm stuffing these numbers. Okay, I don't know whether this logic will work. So to be sure the logic works, you should always try out for n equals to 5 and n equals to 6. Right? You should always. So the first time, if I were in an interview and somebody gave me this problem and I've never heard of this problem, I would sit down with the interviewer. I'll do this quickly. It might take me about 7 to 10 minutes max to work out all these examples. You have to work out these examples fast. Okay? Because in a typical interview, you will be given about 25, maximum 30 minutes to solve a problem like this. In a typical interview at a top product based company. Right? So, okay, so you have to work out these examples. So the moment you work out n equals to 5, n equals to 6, there arrives a pattern. If required, go to n equals to 7 also, it's okay. So when n is even, what are we doing? We are getting strings from n minus 2 and we are stuffing these things in the middle and we are adding these strings in the middle. When n equals to odd, you get strings from n minus 1 and you're going to stuff this in the middle. Remember, when n is odd, n minus 1 is even, which means stuffing this in the middle is logical. Suppose if n equals to 11, let's say, if n equals to 11, n minus 1 is 10. So you get 5, you get 5. You got a concept of the middle, right? Because n is even, right? You can, because n is odd, n minus 1 is even. There will be 5 digits here, 5 digits here. In the middle, plug in this value, right? With this, you got your recursive case. When n is even, you know how to solve it. When n is odd, you know how to solve it. This problem, I told you this problem is medium to hard. The reason it is medium to hard is arriving at the recursive part is the tricky part. Once you arrive at the recursive part, rest of it, if you have done enough practice, this is straightforward and trivial. Okay, once you get this logic, again, what is the boundary case now? Look at the boundary cases that we have solved. Our boundary case will be n equals to 0, n equals to 1, n equals to 2. These three will be our boundary cases. Right? Right? These three will be our boundary cases. Everything from here is recursive case. Right? Very simple. So the boundary case is also straightforward. N equals to 1, again, let's assume, you can also assume that if the interviewer tells you, or you can ask as a follow-up question, is n strictly greater than 0? Most likely the interviewer will say yes. Then you don't have to handle the case of n equals to 0. You don't have to handle it in such a case. Because if that's the case, you have to handle n equals to minus 1 also, no? Then you have to say, okay, this is not valid, etc. So oftentimes you just ask a clarification from the interviewer and say, hey, is n greater than 0 strictly? Otherwise it makes no sense. Okay. Of course, n should also be an integer. Those basic boundary cases you can always add in your code or get a clarification from the interviewer. Okay. Now here is a code that one of my co-founders and teammates Satish wrote for this. Again, don't worry too much about the syntax. Let's focus on the code. Okay, this is Python syntax. Okay, so what he has written here is there is this function called find strobogrammatic, right? And you have an input of length n. Okay, this is a syntax in object-oriented programming in Python, so don't worry about it. This class part and all, you don't have to worry about it. It's very language specific or implementation specific. The core part is this function. This is the core part. Okay, so let me just walk you through this logic quickly. This is exactly the logic that we have. So we'll say even mid candidates are all these, right? This is a string, even mid candidates. Okay, we have odd mid candidates. Okay, again, these two strings that we use, right? If n equals to 1, just return this. If n equals to 2, just return this. You're done. Next comes the other cases. If n percentile 2. So if n is odd, let's assume if n is 5, 5 percentile 2 is 1, which means this is what will run if n equals to odd, right? This is what will run if n equals to even, right? If n equals to odd, what happens? We are creating two variables here. The first variable here is called pre-candidates. The second variable here is called mid-candidates. Again, this is Python syntax. If you don't know Python, don't worry about it. I'll just explain you like English, okay? So the pre-candidates, I'm going to get it from calling the find strobogrammatic recursively with n minus 1. This is exactly the same logic that we have, right? Look at this. If n is odd, we get strings from n minus 1 and we add this in the middle, right? If n is even, we get n minus 1 and add it in the middle. The same logic here in code form. Okay. So the pre-candidates, we're just calling it pre-candidates and mid-candidates. The pre-candidates, when n is odd, this code will run. Right? When n is odd, this code will run. You're recursing n minus 1 and you're using the odd mid candidates, right? Because for odd, you use the odd mid candidates. If n is even, you solve the problem of size n minus 2 and you use the even mid candidates. Right? Very simple. Then here he is finding the middle position, the index of the middle position. Okay. This simple for loop is straightforward now. Look at this. This is a recursive equation that we are solving, right? This whole part now is fairly straightforward. If you think about it, it's fairly straightforward. What are we doing? You're saying for each mid candidate, look at this, for each mid candidate and for each pre-candidate, you're simply concatenating the pre-candidate position. Basically what you're doing here is this. Suppose imagine n equals to, let's say 4, let's just say. You're getting, this is just a syntax in Python. So don't worry too much about the syntax. What you have to do here is, look at this. If you're solving n equals to 4, okay, what you have to do? You have to get this, break it up into two pieces, and in the middle, you add this 1, 1. Okay, that's what you're doing here, right? Imagine if n equals to 5, what do? You get this values of 4. One of the results of 4, if n is odd, if n is odd, you use n minus 1, right? Right? So you get 1, 1, 1, 1 from here, break it into two parts. In the middle, you're going to add this 0, 1, 8. So this whole code snippet is basically doing that. This whole code snippet is basically breaking up the words and inserting, look at this, the C is basically mid candidates. Okay, for each possible mid candidate, it is stuffing this mid candidate in between the pre candidate. Just simple for loop, right? Very simple logic here. Now, again, the actual code itself might vary from problem to problem. Okay, again, for any top product based company, you have to be very comfortable with programming and the inbuilt data structures in that programming language. Okay, because you'll be using that actually to implement, right? Again, this syntax, if you're not a Python programmer, writing this Python code will take a lot of time because you have to do a lot of Google search. So you should be able to write programming or you should be able to translate the logic that you arrive at into programming language of your choice very quickly. So in this session, we are not talking too much about translating the logic into code. We are focusing more on arriving at the logic itself, right? So this is one of the interesting things. Oh, again, by the way, think about the time complexity for this. Okay, so this problem is also an exponential time complexity problem in n. Look at this in n. What is n? N is the number of digits. Now, I want you to think about it. Again, you can easily prove this, but I want you to think about it. Okay, and give a justification. I want to leave this as an exercise. It's very simple exercise. It's not very hard. I want to, after this session, think about it. Why is the time complexity of this logic that we explained, exponential time complexity in n, and put in the comment section. I want to, again, it's not hard. You can easily figure it out. Break down the problem into subparts. Think about it. Okay, so imagine you have n equals to, let's say, 16. What happens? This problem becomes a problem of n equals to 14 plus some recursive time. Similarly, if you have 14, then what happens? The problem goes to 12. This goes to 10. So on. So think about the logic. It's not very hard to arrive at it. I want you to take some time and think about the time complexity. Okay. But the most important lesson that you should understand here is, the most important lesson that I have to tell you here is, again, the key takeaway. This is where 95% of people will get stuck in top product based company interviews. It is working out these examples and coming up with the recursive and base case. Because if you have done ample coding practice, that 5% is trivial. It's not actually hard. It is this 95% which is the focus of this session. Okay, cool. So let's take another very simple problem, slightly different problem. Okay, so 1 second. Folks, okay, let me explain this problem, then we'll go into a Q&A. Okay. Again, some of our students who are from the interview prep course might already know this problem, because variations of this problem we have solved. Again, we have solved over 200 problems with videos like this. Again, what we do in our course videos is, first we understand the problem, break it down with examples, solve it, then we share code. Okay. So here we are only focusing on one part of it, which is how to build that problem solving ability. We are only focusing on one part of it, not all the parts of it. And again, in our videos, in our course videos, what we do here is we give hints. We say, here is a hint, think about the solution. Okay, because students are not in a live session there. We say, pause the video here, think about the solution. Okay. And again, so this is one of the problems that we have solved there, or variation of the problem. Okay. So the question here is this. Again, this is a very common problem. Okay, very common problem. Some variation of this is very much asked in lot of programming interviews. Suppose you are given a matrix which is of size m cross n. So this is a 5 rows, 4 columns matrix. Okay. In this matrix, you want to start, or think of it like a grid. Instead of matrix, think about it as a grid. You want to start from 1, 1 cell. This cell is first row, first column. And you want to arrive at the last row, last column. Okay. But to start from this place and arrive at this place, you can only move right or you can move down. You can't move in any other direction. Okay, that's the key here. That's the key. You can't move in any other direction. Okay, very, very important. Now, how do you solve this problem? Okay, think of recursive case first. Okay, very, very important. So somebody is asking about doubt clearance. I'll surely answer your questions from 8:30 onwards. I wanted to solve 2-3 problems here. Again, there are many ways of solving this problem. This problem can be very optimally solved, or there are multiple solutions to this. You can also solve this using dynamic programming, but today we'll solve slightly non-optimal solution using recursion. Because once you arrive at the recursive solution, arriving at the dynamic programming solution is fairly straightforward. Okay, so in this session we'll focus on recursion, but there is a better implementation using dynamic programming. Okay, I understand that. Very good. Okay, so I'll surely try and answer as many questions as possible from 8:30 onwards. Let's finish. This is a simple problem. Now look at this. How do you break this problem into subparts? Again, always work out examples. That's the most important part. Okay, again, the solution that we are discussing now is not the most optimal solution, but it is a simple recursive solution. Okay, so cool. So let's go into the recursive case, right? Suppose you are here. Suppose you are initially at 1 cross 1. Okay, you want to go to, okay, so I've already written it here. So why not write it? Why write it again? Suppose you're in 1 cross 1 cell and you want to arrive at 5 cross 4 cell. Okay, you want to print all the paths that you have. Now look at this. From here, you can only go to this cell, which is first row, second column. You can go to 1 cross 2, and all the paths that you have, from this cell to the final cell. Look at this. So suppose you have a bunch of paths. Okay, so from 1, 2 to 5, 4, you can have, let's assume some k paths are there. In all those paths, if you want to find paths from 1 cross 1, you just add 1 cross 1 to 1, 2, and all these k paths. There will be multiple paths here. There will be multiple paths from this cell. That's why I'm writing this jiggle line. This jiggle line basically means that there are multiple paths from here to here. So all the paths that you have from 1 cross 2 to 5 cross 4, to that, if you just append this path from 1, 1 to 1, 2, you get all the paths from 1, 1 to 5, 4. Not exactly. Because from this place, you can also go to this place, no? You can also go to this place. Look at this. You can also go to this place, no? Think about it. So, all the paths that you have here is, get all the paths from 1, 2 to 5, 4. So, let me write it down. All the paths from this cell to the final cell. To that, append this path. That's one option. And the other set of paths that you can have here is, because you can go right or bottom. So, go from this cell to this cell. What is this cell? This cell is second row, first column. So go from 1, 1 to 2, 1. From 2, 1, there will be multiple paths to 5, 4. There could be some k dash paths to 5, 4. From 1, 2 to 5, 4, there could be k paths, right? So if you want to get all the paths from 1, 1 to 5, 4, it is nothing but paths from 1, 1 to 1, 2, which is a valid path, and all the valid paths from 1, 2, all the k valid paths from 1, 2 to 5, 4. And similarly, the path from 1, 1 to 2, 1, and all the valid paths, all the k dash valid paths to 5, 4. So if you want to print all the paths, you can just concatenate 1, 1 to 1, 2 and then print all the paths. Right? Very, very simple logic here if you think about it. Again, our objective here is to print all the paths, not just to count. Okay? Cool. What is the boundary case here? So recursion is very simple. Again, this is a very, very standard problem in dynamic programming and recursion. Very straightforward problem. Again, here you are breaking a larger problem into two subproblems, and the combination or concatenation of these two subproblems gives you the final problem, the solution to the bigger problem. Sort of like Fibonacci, right? You have a problem which is larger, it is broken down into two smaller subproblems, right? In Fibonacci, both of them are of two different sizes, here roughly the same size. Okay, cool. So with this logic, what is a boundary case? Your boundary case here is, if you want to go from 5, 4 to 5, 4, you can't go anywhere. This is one boundary case. Similarly, if you're in this cell, you can't go bottom anymore. You can only go right. Always remember that case that you have to handle. If you're in this cell, you can only go right. You can't go bottom because there is nothing here. Right? That's an important case. Similarly, if you're in this cell, you can't go right. You can only go bottom. These are boundary cases that you have to handle. Now, given that, the code for this is actually very straightforward. Okay, I'll just explain you the pseudocode here, simplified pseudocode. So the question here is find paths. Okay, let's assume it's called find paths. All the paths are, let's assume, in this data structure paths. You can store it as a set of strings, or you can store it as whichever, or you can store it as a string. You can store it as a list of strings, depending on the programming language you're using, or you can use it as an array of strings, whatever you want to use here. Okay, this is the start row, start column, end row, end column. Okay, first let's handle the boundary case. What is the boundary case? if SR equals to ER, okay, if the start row and end row are the same and start column and end column are the same, then just print all the paths because you have reached the destination and return. This is the boundary case because you're not going to recurse anymore. Okay, so this is your boundary case. Okay, this is your boundary case. Very simple boundary case if you think about it, right? Else, what do you want to do? You already have, so when you're being called, you have some paths already here, right? All you do here is just add the current node. Okay, whatever is the current node. For example, you're coming, suppose this is your current node. For example, this is your grid. Okay, suppose this is your current node. Okay, add the current node to each of the paths that you have. Append this grid, append this cell. This is the row and the column of the source that you're getting. You'll just append it to all the paths because you're encountering this cell, no? Then you do two things. First, you check. Again, there are two other boundary cases that I was talking to earlier about, right? So, for example, if ER is greater than SR, okay, if the destination, if the source row, okay, if the source row is less than the end row, if the start row, okay, if this is your start row, if it, so these are your rows, right? These are your rows, okay. So this is your end row, okay. This is your end row, okay. If your source row, for example, if you are moving from here, okay, your source row, suppose this is your source, this is your destination, okay. This is your source, this is your destination, no? So if you're going from here to here, and if your source row is less than your destination row, then you can move down, no? Otherwise you can't move down. So only when end row is greater than source row or source row is less than end row, whichever way you want to write it, you will say find paths. You will now increment the source row because you've moved down, no? See, you've moved down. How do you simulate moving down? You increase the row number, you don't change the column number, the destination doesn't change. The end doesn't change, only the starting changes. And all the paths will anyway get added to this. Okay, the implementation of paths, you can do it as an array of strings or a set of strings, right? Whichever way you want to do it. Okay, or a set of or a list of strings. You can do whatever you want there. Okay, that's implementation specific corresponding to the programming language you're using. Similarly, if, okay, there is another case. If end column, so these are your columns, right? These are your columns. Okay, so this is your end column. This is your end column. If your source column is here, then you can always move right. But if your source column is here, you can't move right, right? So if your source column is less than your end column, move right. What is moving right means? Moving right means incrementing the column number without changing the row number. That's it. Very simple logic here. Very, very simple logic. That's it. You're almost done. And when you start, what do? You say find paths. This is the starting cell. This is the ending cell. You give your path as, if you're implementing it as a list or you just give, if you're doing it as a list of strings, you can just give a list of empty string, right? Again, it's also very easy to prove that, again, this is not an optimized code. Okay, those of you in the comment section, this can be solved better using dynamic programming. I completely understand it, but we'll discuss this problem again when we arrive at dynamic programming or a problem similar to this, if not the same problem. But this problem can still be solved using recursion itself. And when you solve it using recursion, it is fairly simple to show that it has exponential time complexity. Again, I can give you a very simple logical argument. Okay, logical argument here is, at any place you have two options, right? At any place, look at this. If you have n rows, okay, and let's say you may have n columns also, just for simplicity. Okay, you have two possibilities here, right? Similarly, here you have two possibilities at any place. So from here, you increase the row number or you increase the column number. You increase the column number or the row number. So you have two possibilities at every place. And you simply have to go through n rows and n columns eventually. So you have to make n right, you have to make n right turns and n bottom turns if you have an n cross n matrix. Right? Every place you have two choices. So if you think about it, it's very easy to argue that it's exponential time complexity. Again, think about it. I'm not going step by step into the time complexity because that's not the focus here. Again, solving recursive time complexity problems can take a lot of, if you solve it rigorously mathematically, it can take a lot of time, but intuition like this will surely help you. Again, in the comment section, please put in your intuition on why it is exponential time complexity. Again, by using DP, you can improve this. Okay. So, okay, so those were the topics that I had quickly. It's already 8:15. So I want to spend the next half an hour answering your questions in the chat window. Okay. So let me go one by one. I'll just change the screen here, or let me keep the screen as is. Again, I'll just write whatever is here. We are trying to find, somebody's asking this question, Anirudh, who's asking, we want to find all the routes, not one route, Anirudh. So that's why this is there. Okay. So Sitaram is asking, are there any pointers to analyze time complexity? I mean, the best way that I know is the recursive tree method. Okay, since you asked at it. So this is one of the simplest methods to do. I mean, there are also master theorem and all that stuff. Okay. Again, CLRS is one of the best books that you can think of. I'm not saying it is the best book. It is one of the best. It is one of the best books that I know. Okay. So recursive tree method. Recursive tree method is what is used extensively by people to make arguments about time complexities. Especially for recursion. Or those of you who know master theorem, again, master theorem only works in some cases, not all the cases, and you have to remember a lot of boundary cases. In most interviews, people end up using the recursive tree method for time complexity and space complexity. Okay. So again, you can just Google search for it. There are a lot of very nice notes on recursive tree method. So just type MIT OpenCourseware CLRS. Okay. Because all of the MIT OCW algorithms and data structures course is taught from the CLRS textbook. Again, when I was a student at Indian Institute of Science, all of data structures algorithms was taught from CLRS textbook, right? It has one of the best explanations, and you can actually improve things. Okay, cool, sounds good. Again, anybody who wants to know more about the course, I don't want to discuss it here. Just feel free to check out here. It's called interviewprep.appliedcourse.com. Again, if you have any questions, there is an email address there. There is a phone number. Feel free to reach out. Again, this course has been designed specifically to help working professionals and students to crack SDE 1. Right? These are people typically with 0 to 3 years experience at top product-based companies. Okay, so if you're interested, go check out there. I mean, instead of explaining all the details here. Okay. Yeah, somebody is asking what is the time complexity of the S number problem. I think I mentioned this, right? I mentioned that it is. Didn't I mention it? I said it's exponential, right? I said it's exponential time complexity. And please, I want to see your thoughts in the comments window. So please explain why you think it is exponential. If nobody answers it, I'll put an explanation text in the comment section later. Okay, think about it. Cool. Amit has a question. Can a fresher get a machine learning or data science job in product-based companies if he has sound coding skills? Yes. So in top product-based companies, okay. So let's take Amazon as an example where I've worked for a long time. So if you come from CS background, you will have one interview on data structures and algorithms, right? Or if you have worked as a software engineer earlier, there will be one interview like this. You will have about 4 to 5 interviews on mathematics, the foundational mathematics like probability, statistics, linear algebra, etc. You will have typically rounds which check your machine learning breadth, what all techniques you know and things like that. Machine learning depth, how well do you know these techniques, and how well can you apply these techniques to real world problems. Okay, again, in top product based companies like Amazon, there is a lot of focus on the underlying math. Okay, and also your ability to code data structures algorithms. Again, if you do not come from CS background, let's assume you're a mechanical engineering student who is very strong in all these things, they will ask you some programming, because I have interviewed people from all sorts of engineering, physics, math backgrounds. We don't ask too much of data structures and algorithms specifically, but we still ask some programming, like simple recursion. We expect people to know recursion, and we ask a recursion problem. We don't expect you to solve it using dynamic programming or some graph algorithms or anything, but we expect you to be able to write some simple recursion problems, not complex ones. Okay, I hope this answers the question. Yes, Abhijit has a question. Very good, Abhijit. So you said the grid traversal problem, right? So you're saying the grid traversal problem looks very much like an n-queens problem. You can think of it, again, all of these are related, right? If you solve backtracking problems or recursion problems, there is, I mean, they all are very similar. right? So they all are very, very similar. Very good question. Harshit has another question. So let me call it out. Very good question, Harshit. Harshit asks, for QA engineers in top product based companies, what will be the difficulty level? Very good question. So for QA engineers, at least I don't have too much experience with QA engineers, but I have seen a few interview loops of QA engineers. So my knowledge is limited, to be frank with you. So what they typically ask is, you should be able to code you should be able to code Python code very well. Python, Perl, any of these scripting languages. You should know shell scripts well. You should know SQL very well. Again, there is not too much of expectation about data structures and algorithms. They don't ask you some hard data structures algorithms. They might ask you simple recursion problems, simpler than what we are seeing today. Okay, simpler recursion problems. And you will encounter a lot of problems around arrays and strings. Simple problems around arrays and strings. Okay, fairly simpler problems. Okay, so the hiring bar for QA engineers is significantly lower than software development. So if I have to write the bars, right? Software development engineer has the highest bar. The bar is very similar for SDE testing also. Okay, very similar bar, not much of a difference. Then you have data science or machine learning. So actually, to be frank, actually machine learning engineers, then comes machine learning engineers, slightly lower than SDEs. Below machine learning engineers will be data scientists. Your QA engineers is somewhere here. Okay, roughly speaking, this is the hierarchy. This is the hardest roles in terms of programming questions. SDET is very similar to SDE. This is software development engineer testing. Okay, these people actually build all the testing frameworks. Okay, QA people they also write a lot of QA related code, but they also might do some manual, some automated testing and things like that. So your data scientist is lower than, so machine learning engineer slightly lower than SDE. Okay, cool. Okay, Mithul, very good question. I'm happy people are asking brilliant questions today. So Mithul has a question which is how to build this recursive skill. Okay, very good question, Mithul. So my suggestion is this. Okay, just go to Google. Okay, just go to Google. Okay, just type in recursion problems. Okay, if you just go to Google and type recursion problems, see, you have so many problems from places like Geeks for Geeks, Techie Delight. Oh, I like this also. This also is very good. So there are tons of problems here. Okay, Techie Delight is good. Geeks for Geeks, Lead Code. There are Hacker Earth. Okay. Oh, there's also nice lecture notes from Stanford. There are tons of places. There are literally thousands of problems that you look at this. All the backtracking problems, all the string problems, all the array problems, divide and conquer, sorting. Tons of problems here. The only way I know to become, again, how do you become good at problem solving? This is a question that a lot of students ask us. Okay. How do you become good at problem solving? Let me tell you how you become good at it. Okay. There is no trick. You have to know first the basics and you have to practice. Again, different people have different ability. Somebody might become very good by solving only 100 problems. Others might require 500 problems. The number of problems that you have to practice might change. You have to know the basics, the basic concepts. Then comes practice. There is no shortcut to this. Okay. What we recommend students is, so that's why in our interview prep course, we have solved 200 problems, just over 200 problems for you. Okay. And we have 300 practice problems. And what we do here is, in these 300 practice problems, after we solve a problem, we ask you to check out similar problems and solve them. Again, imagine when you are in your 8th class to 10th class, right? You had maths. Okay, you had time and distance problems, right? All these the so-called aptitude problems that you encounter, they're all your 8th to 10th class math only, no? Time and distance, your water flow problems, right? All these problems. How did you become good at it in your 8th and 10th class? By solving hundreds of problems. How do you become good at calculus in your 11th and 12th? By solving hundreds of problems. Again, I'm not saying everybody has to solve 500 problems. Okay, but 500 is a good enough number. That's what I would recommend. I've seen people who can solve 100 problems because their problem solving skills they have built. Again, one of the most important things. Again, think about it like this, right? You have CAT exam, which is one of the most competitive exams in India. They only check your aptitude and reasoning. And of course, English. Right? And this aptitude and reasoning and verbal, your aptitude and reasoning syllabus is very much similar to what you have in your high school mathematics. right? Nothing more than that. What they're testing is your problem solving skills. What Amazon, Google, Facebook, all of them are testing are two things. Do you know programming? Do you know basic data structures and algorithms? And can you solve problems? Simple. Because they know that if you have, again, problem solving is sometimes called as a transferable skill. What is a transferable skill? If you are good at solving time and distance and water flow and problems like this in your high school, if you learn the basics of programming and the concepts of data structures and algorithms, you can become good at it with fewer problems. If you are not good at it, you will need more problems. You will have to practice more problems. So once you're good in problem solving skills can go from one domain to other domain. That's why in CAT exam, they test your problem solving in basic aptitude and reasoning. If you're good at it, you can apply this to business problems, right? Similarly, Amazon, Google are testing, do you know the basics which you have to use on a day-to-day basis? Again, some finance companies have aptitude rounds in their interviews. Why? You don't use that aptitude. They're testing your problem solving skills. And problem solving skills have to be built through practice. To be honest with you, imagine if I'm interviewing, hypothetically, okay? If I'm interviewing for a SDE1 role at Amazon today, fresher role. Imagine if I'm doing it. My strategy will be very simple. I will take up 200 different questions, okay? And I'll solve each of this question without looking at the solution. I will solve each of them and I'll write code for each of them. So I can fix a programming language. For example, imagine there is Python programming language. I will solve at least 200 problems, at least 200. If I have to go for an interview today for a software engineer one role at Amazon or Google or any company, again, I've interviewed for slightly more senior roles at companies like Google, Amazon, etc. And I actually solved hundreds of problems. I actually solved hundreds of problems like this before I went for the interview in the past. I've done this myself. Because it is only by solve the problem, but don't forget to code. Because if you get the logic, but if you can't code, that is a concern that you're good at problem solving, but you're not able to write code. Companies want both. You should be able to write code. Pick any major programming language. I will solve at least 200 problems if I have, let's say, like simply speaking, right? You should be able to solve about 10 problems a day. Sit on it. Again, the first time you start with easy problems. Then go to medium problems and then go to hard problems. Right? Just do this step by step. At least 200 problems. There is no escaping the fact. There is no escaping that fact. You take the smartest of the smartest engineers in the best universities of the world. If they have to interview at Google or Facebook or Amazon, any of these companies, I'm sure they would practice few hundred problems even though they're very good with the concepts. Because this practice helps you enormously. There is no shortcut there. Okay, that's how you build the skills. Cool. One second. How can this recursive skill help data scientists in specific? A very good question. So again, for data scientists, it's a good question, Sitaram. So the question here is, why is recursion important for data scientists? Why do companies ask these questions? Two things. They want to test two things for you. Can you code? Okay, can you code in a modern programming language? And recursion is a very fundamental concept. So they want to test, do you have problem solving skills? Do you have this is a test of general problem solving skills. To test general problem solving skills, they can ask you programming questions. They can give you aptitude questions, or they can give you something like a hardcore math question from machine learning or data science. Okay. So most product-based companies don't ask aptitude questions as many. There are some finance companies like Goldman Sachs, etc., which have an aptitude round. But most, again, in our interview prep course, we also added aptitude round just for those companies, right? But for a data scientist role, they want to test your problems. See, they want to test your problem solving. They want to test your knowledge. They want to test your knowledge. They want to test your code. What is the best way to test code and problem solving in one shot? Give a slightly tricky recursion problem. Right? Because you're expected to know recursion. For knowledge, so they also mix up knowledge and problem solving. Okay? So they can ask you a question about some question about linear algebra, probability statistics, where they'll give you an interesting problem and say, how do you tackle it? There you have to use the knowledge of machine learning techniques or data science techniques or probability or statistics or linear algebra and still have problem solving techniques. If you only have problem solving techniques, suppose for example, if you can crack CAT, okay, let's take this. You have very good aptitude, right? Very good aptitude, very good reasoning. But if you don't know how to code, Google may not hire you for software engineering roles because they want people who can code also. Google may not hire you for a machine learning role because they want you to have the knowledge of machine learning. So they're going to test 3 basic skills: your ability to code, your knowledge, foundational knowledge of the concepts, and problem solving skills. The best way to test this is through recursion problems, because they're testing how do you think in an actual real world situation. How do you think? They want to see that thinking process, right? So recursion problems is one way to test these 2 skills. Cool. So let's go here. Sudhansh has an answer. Okay, Sudhansh has an answer about time complexity and how it can be eliminated with dynamic programming. You're right, Sudhansh. Yes, you're right. Let me look at some more comments. I just go slightly back and I'll try to answer. So what role do you suggest for a person who is perfect in mathematics and problem solving skills? So this is again a question from Sudhansh. So he says, if my math is super good, I'm assuming you're saying math with respect to data science and machine learning. Okay, if that's what you're saying. Okay, your math is superb, 5-star, but your coding is below average, is about average, let's say. Then I would say, spend 3 months, because if your problem solving skills in math are good, you can pick up coding and become good at it in 3-4 months. Become good at it and try for machine learning engineer or data scientist roles at top companies. That's what I would recommend. If on the other hand, you're saying your math is good from the perspective of aptitude, not machine learning. If your aptitude math is very good, which means you can solve hard problems in CAT fairly easily, let's say. Okay, or you can solve them reasonably well. Okay, suppose you have that problem solving skills of aptitude and you say, hey, I'm average at coding. First become good at coding and look for software development engineers at product based companies. That's what I would recommend. Because if your problem solving skills are good, all you have to do now is you have to practice a few hundred problems. Like when I was at Indian Institute of Science, or even after my previous startup when I wanted to go back to the industry, I mean at IISc I think I solved easily. I mean my whole class sat down and solved I think about 300 problems together. We all sat down, each of us got some easy, medium, hard problems. We solved them day in, day out. Like in 15-20 days we solved it. Of course, most of us have very good problem solving skills. Most of us had our gate ranks were mostly single digit, double digit ranks, right? So we had very strong computer science foundations, but we still practiced hundreds of problems, right? When I was interviewing with Amazon and other companies, almost with 2.5 years experience, both startup and Yahoo Labs experience, I solved, I think, close to 200 practice problems. Because I know that they will ask me, one round will be data structures and algorithms. The rest of the rounds are all machine learning, data science, like hardcore math rounds. But I know there is one round for data structures and algorithms, and I know I can't mess it up. So I think I solved close to almost 150, 200 problems then. Of course, I solved I also read and answered and read through a lot of math for machine learning, data science, but I also did this. But yeah, I was asked a very simple question from data structures algorithms, which I solved very quickly, but you could be asked harder questions. Okay. So this is what I would recommend. Mayank is asking, is there a course on big data? We want to do it, but currently we don't have the bandwidth. So in case there is something as and when we have something working, we will surely let you know. Okay. So any good stats books? So there is this book called Think Stats, which I recommend a lot of students. So this is from O'Reilly, if I'm not wrong. There is also our Greenpeace publication. Just Google search for it, Think Stats book. The reason I like this book is this is very applied book. This is not a theoretical book. This book takes real world data and introduces concepts from that applied perspective. Okay, very nice book. I've recommended this to a lot of students, both at Applied AI course, at Amazon, elsewhere. I mean, it's a very nice applicative book. So I would recommend that because that will help you enormously in your careers of solving problems. Cool. One second. Monica is asking, is HackerRank kind of platform sufficient to practice? More than sufficient. Again, you can pick up any of these HackerRank, LeetCode, any of them. Try to solve 200, at least 200 problems. See, if you're anyways good at programming and all that, try to solve about 200 problems. If you are mediocre, try to solve about 400 to 500 problems. Okay, try solve these. You can pick any platform. There is no dearth of platforms for practicing. Okay, practice from anywhere, but don't look at the solution. Very common thing that we see students doing is they see a problem, they get stuck, they see the solution. You're not learning anything. Struggle with the problem for a while. Even my suggestion is struggle with the problem for a few hours. If you can't solve it in the early days, see the solution, but try to avoid seeing the solutions as you keep practicing. First 50 problems, probably you're seeing the solution once in a while, but going forward, try to struggle with the problem, because your problem solving skills will only benefit if you see a solution. No, your problem solving skills won't benefit much. You have to struggle. That struggle is very, very important, right? It's like your gym. You don't build muscle or you don't become a good marathon runner by taking shortcuts, right? So that's what I would recommend here. Oh, another question. This is about Varun has a question, which is between software development engineer roles and machine learning roles, what is the pay difference? So a software development engineer, if he makes X, a machine learning scientist, okay, this is it's also called as applied scientist in some companies. This type of role will easily get you about 1.3x to 2x. Okay, a data scientist is lower than software. Again, different companies use different naming terminology here. I'm just talking about general. So data scientists, unlike a machine learning scientist or an applied scientist, is slightly less paying. Okay, so not slightly, sorry. So a data scientist might make about 0.6x roughly to 0.7x. I'm just making up I'm just making rough numbers here. Okay, these are rough numbers from our own experience. Similarly, if you're a machine learning engineer, okay, you can easily get 1.3x, approximately 1.3x. Okay, so the requirements in terms of skills are, again, very importantly, SDE, data structures algorithms, good in programming. Okay, applied scientist, machine learning scientist, you are good with standard programming, data structures algorithms. So data structures algorithms, but you're very strong. You're very strong in machine learning, deep learning, data science, math part, the foundational math and applied aspects. Okay, machine learning engineer, you're decent. You're decent. You don't have to be as strong as a scientist, but your programming skills must be like an SDE level. Plus, you know machine learning and data science reasonably well. That's what a typical machine learning engineer is. A machine learning scientist typically gets almost 1.3 times also. A data scientist, on the other hand, knows machine learning and deep learning and data science, doesn't have the depth of a scientist. Okay, the mathematical rigor the depth doesn't have. They know SQL well. They know decent amount of programming, basic recursion and stuff like that. And they typically, of course, they also work on models and all that. So typically these are the 4 types of roles that you will encounter. So the best paying roles obviously are your machine learning scientist or applied scientist roles. You have machine learning engineers and you have software development. Again, these are the terminology and names might change from company to company. Okay, for example, there could be some companies which call their machine learning scientists as data scientists. Like when I joined Amazon, my business title was data scientist because the job family of machine learning or applied scientist wasn't there. Then they created this job family and of course my salary also increased then. Okay. So again, this is general broad numbers that I'm giving you. Okay, at product-based companies only. Okay. Sandeep has a good question. Very good question, Sandeep. So you're asking a good question now. Sandeep says, I'm a web developer. Okay. By web developer, I'm assuming you're a front-end developer. Okay. I'm assuming you're a front-end developer. How much data structures and algorithms should I know? So most product-based companies have a role called front-end engineer, which is different from software development engineer. A software development engineer needs to be very strong in data structures and algorithms and programming. But the programming language, there is nothing that is stopping a specific programming language. For a typical front-end engineer, you have to be very good with JavaScript, typically JavaScript and other similar technologies, right? Front-end technologies. Again, some companies ask for front-end framework. Some companies say, as long as you're good with JavaScript, we don't care. the data structures and algorithms bar for them is certainly lower. So you might have one round or maybe 2 rounds of basic data structures algorithms. Okay, or you might be asked real world problems where you have to use, let's say, a queue or a stack on your web browser to stream data and things like that. So the bar for data structures and algorithms for front-end engineers is lower than software development engineers, but they will have very specific front-end engineering interviews, right? So those are slightly different roles. Okay. How much? Okay, so the other question here is for DevOps. How much data structures and algorithms is required? Again, DevOps is very similar to your front-end engineer. There will be some data structures and algorithms, not surely at the level of a software development engineer, significantly lower than this. But a DevOps will have very specific DevOps stuff, right? Like for example, your Docker, Kubernetes, right? So all these deployment platforms and things like that. Okay, so they will have they might have 1 or 2 rounds on data structures and algorithms, but significantly easier than a software development engineer at product-based companies. But they'll have more DevOps specific roles, right? So cool. Okay, cool. So I'm from mechanical engineering. So Rishabh asks a question. I'm from mechanical engineering. Is there a chance of getting into product-based companies in machine learning data science roles? Yes. So I have personally hired mechanical, electrical, like one of my best teammates was actually electronics engineer, right? So if you're a non-CS guy, the programming bar will be lower. You will not be expected to know dynamic programming, some graph algorithms, etc. But you have to do at least 1 round there where you should be comfortable with recursion and programming. From a mechanical engineer or a non-CS engineer, the expectation on the math is higher because you guys are supposed to know vector calculus better than a CS guy, right? So the mathematical depth expectation is higher from non-CS engineers. So they will ask you harder problems on let's say stats, right? Linear algebra, vector calculus, right? So vector calculus, mathematical depth, optimization algorithms, machine learning, in depth they will go in. While the interviews for programming and recursion will be slightly easier than CS folks. So you don't have to be an expert in all these advanced data structures or even in data structures that you may not have studied, but you should be able to solve programming and recursion like slightly harder problems. Okay. Cool. Cool. So where are we? So Sai asks a question, is recursion explained in detail in applied AI course? Yes. So in the Python part, we first introduce the concept of recursion, the basic concepts of recursion, because some students may not even know Python or recursion. So we introduce these basic concepts. Then at the end of the Python chapter, we have a bunch of live sessions, okay, where we have solved ton of recursion problems. And in the course videos and in the course assignments, we have ton of practice and explanation of recursion problems as and when we encounter them in machine learning context, right? So these are covered in the applied AI course also, but certainly not to the same degree for a software development engineer. For example, in our interview prep course, we have solved, tons of problems. I don't have an exact count, but I'm sure we have solved easily some 40 plus problems on recursion or something related to recursion, maybe even more. I think we have solved easily about 70, 80 problems on DP alone. Right? So in our interview prep course, we have focused much more than in our machine learning course, right? And the reason for it is, for machine learning people, some of these questions are asked, but not to the same level as a software development engineer, right? And we had to make trade-offs. We didn't want to make the machine learning. See, if you explain all the concepts that are there in our interview prep course, which is close to almost 180 hours now, right? If you add everything to our machine learning course, this will become massive that nobody can complete. So we made some trade-offs. But whatever we have, the assignments in the machine learning course, the concepts are fairly good enough for most roles in most companies. Okay, cool. So Manoj has a question. His question here is how to improve English communication in interviews. Okay, so this is something that I read about Professor Andrew Ng. A phenomenal professor, the founder of Coursera. Again, a huge inspiration for many of us at Applied AI course also. So he also has a very beautiful machine learning AI courses on Coursera and things like that. So Andrew Ng, in his first year as a professor at Stanford, was voted one of the worst professors by the computer science department students. He said, because he was not communicating and explaining concepts clearly. So his solution is one of the best solutions I've heard. He said, I will take up a concept, maybe 10 minutes or 15 minutes. I will sit in front of a mirror, or I will use my selfie. I'll use a camera. Okay, this was a few years back before selfie cameras became popular. Okay, he would take up a concept, explain that concept in the mirror or record himself and see how he is explaining it afterwards. Okay, he will see how he is explaining it. Same concept, he will repeat it till the time his explanation or his communication becomes better. Again, like many things in life, practice is the essence. But this suggestion by Professor Andrew Ng is one of the best suggestions that I've seen. Take up a concept, try to look at yourself in a mirror or record using a camera, and once you're done, you'll get stuck at a few times, right? Keep doing it multiple times. Within 3 to 4 months, you'll see significant improvement in your communication, right? See, hard work is hard. A lot of people want quick fixes, right? Everybody want a quick fix. But to build key skills in life, there are no quick fixes. There is only effort. Again, what I'm recommending here, which is suggested by Professor Andrew Ng, is a smart preparation instead of blunt preparation. So try to put in like roughly, let's say 1 hour every day, or at least 5 hours a week on this task. Every week, try to record a 10 to 15 minutes video and keep improving over a period of time. And you will become better in just a few months. This is one of the best suggestions that I've heard. Right? Cool. Satish Agarwal has a question. You're a first year student and you want to decide between machine learning and SDE. So if you're a BTech first year student, I think I've done a video on this on our YouTube channel. My suggestion is very simple. If you're a BTech first year student, first become good at one of these major programming languages. You can pick up Python, right? Become good at a programming language, become good at data structures and algorithms. This is what you should do in your first year and even in your second year. Just if you want the best textbook, or one of the best textbook I should say, is CLRS. Corman, Leeserson, Rivest and Stein, Introduction to Algorithms. Okay. First and second year, become good at this. You can focus on machine learning in your third year or fourth year because once you're good at software development engineer, programming, data structures, algorithms, then in your third year, you can either choose to pursue machine learning, or you can say, hey, I want to become a full stack developer. So I want to become a full stack developer, or I want to become a big data developer. Okay. Big data developer. So that choice you can make in your third and fourth year. First and second year, first become good at Python, data structures, algorithms. Also focus on some of your core subjects, like you'll have databases, you'll have operating systems, you'll have computer networks, compiler design, theory of computation. Go through these subjects thoroughly from good textbooks. So that in your third and fourth year, whether you choose, your whole big data is nothing but a combination of databases, operating systems and computer networks. Right? Your full stack development is JavaScript with some computer networks and mostly basic programming. Right? Of course, in your full stack development, you'll also use some databases and some concepts from operating systems in a few places, especially in the backend. Right? So my suggestion is don't worry about it. First, become good at programming, data structures, algorithms. You can think of others at a little later point in your education. Okay, cool. Nirai Arasu, right? His question is, I've just finished my BTech in information technology. How much data structures and algorithms should you know? Everything that I've discussed in this session, you should be able to solve each of these questions in about 25 to 30 minutes if you want a good product-based company. Because you have done from a core computer science field, you should be able to solve dynamic programming, graph algorithms, arrays, strings, all of that stuff. So pick a programming language of your choice. It could be Python, Java, C++, whatever you want. Okay. Python is easier typically. You should be able to solve these data structures algorithms problems that I've been talking about for the last couple of hours, you should be able to solve them in 25 to 30 minutes per problem. Since you come from a CS background, you should be able to solve problems around graph traversals, problems around dynamic programming, some array problems, all of that stuff, right? That's what is expected in a top product-based company. Cool. So Ram has a question, Ram Arun. He says he has 12 years of experience in data warehousing. So what is the scope, data warehousing and business intelligence? What is the scope for him? See, since you have so much expertise in this field, a logical transition for you would be to go from, again, data warehousing, you know, a lot of database concepts, business intelligence, you know, some pipelines, probably some tools, etc. Try to pick up big data tools like Spark. Okay, become good at fundamental Spark programming. Okay, Spark, Hadoop, NoSQL databases, right? These are the stuff that you want to become good at. When I say good at, what I mean here, again, I'll tell you an example. So a logical transition for you, given that you have these skills, one logical transition is to become a big data engineer. And as a big data engineer, let's assume you're a Spark engineer. Okay. So I've done some interviews of big data engineer roles at companies like Amazon. And I'll tell you a simple question. One of my favorite questions always was, how do you implement, can you write Spark native code to implement a distributed join? So you have two tables, you have two big tables, you want to implement a join optimally. Okay, so I'll give you some constraints on the size of table A, size of table B, how they're distributed, all that stuff. Okay, I'll change this problem slightly from person to person. And I'll say, how do you implement distributed join? Can you implement it in Spark? And try to get the best implementation. So a lot of people will use a NoSQL database or will use something like Hive and say, hey, I'll just write Hive code. No. I want you to tell me how is the distributed join implemented in Hive? Because that's the only way I know that you have the depth of knowledge. Okay, so this is one path that you can follow. The other path that you can follow is, you can say, hey, I have worked a lot of data warehousing and business intelligence. So a logical transition is to data science careers. So since you have 12 years experience, you have to build on top of your prior experience. Okay, you have to build on top of your prior experience in data warehousing and business intelligence and say, hey, because I know some of these tools, I'll become good at data science, because data science is a logical extension to a lot of business intelligence stuff, especially if you're doing data analysis, plotting, simple models and things like that. So this is another transition that you can think of, but you have to build on top of your skills, right? For product-based companies, if you're somebody with 12 years experience, the interview will also be slightly harder, obviously. Cool. So what is the scope of marketing and web analytics, Google, Adobe Analytics, Power BI, etc. with 2 years experience? Again, I'm not an expert in those tools, to be honest with you, but I do see, the logical thing is you should ask somebody who is in a product-based company doing those roles, because I've never hired for those roles. So I don't want to comment on it with half knowledge. So Abhijit has a question about base cases. Base cases is not a, so he says, is the base case to ignore irrelevant, irrelevant. Okay. After spell correction, I have forgotten spellings, to be honest with you. I think the spelling is wrong, but that's okay. Google chalta hai. Okay. So the base case in any recursion problem, okay, the base case in any recursion problem, it is not to remove irrelevant stuff. It is to say, when should the recursion end? When should you stop recursing? When should you stop recursing? Because if you keep recursing, when does this end? It could go into an infinite loop or infinite recursive structure. You want it to stop somewhere, right? That's what is your base case or your boundary case or your stopping case in recursion, right? So, okay, another question here is for SDE1, what are the requirements apart from data structures algorithms? For SDE1, 90% of your interview will be programming, data structures, algorithms. 10% of your interviews could be little bit of SQL, little bit of databases, little bit of computer networks, little bit of concepts from operating systems, etc. That's why in our interview prep course, what we have done here is we have focused 90% on programming, data structures, algorithms, but we have added content for SQL, We've added content for little bit of content for database normalization, little bit of content for basics of computer networks and protocols, basic concepts for operating systems, etc. Okay, basic concepts. We did not do too much of it because only 10% chance that questions will be asked in this, right? But now, if you're good in this, even if you mess up databases a little, mess up CN a little, mess up OS a little, it's still okay. Okay, cool. So, Brijalta Kumari, she's asking ML versus SDE. See, it's a call you have to make, no? See, it's a call that you have to make. Okay, so I've been giving you options for the last few for the last few minutes. ML versus SDE. For SDE, again, let's keep ourselves only to product-based companies. For SDE, you have to become good at programming, DS and algo. For machine learning roles, if you come from CS background, you have to know these things. Plus, you have to know stats. You should know programming for sure. Data structures algorithms, not so important because the questions will be much simpler. Stats for sure. Linear algebra, optimization, tons of machine learning techniques, deep learning techniques, plotting, bunch of tools, productionization, etc. So the number of concepts for machine learning certainly is more than SDE, but the hardness of SDE is also non-trivial. Okay, there is a lot of competition because the syllabus is smaller. There is a lot of competition here also. Okay, so it's a choice that you have to make. If you are very passionate about machine learning, if you are very strong in mathematics, you should certainly consider machine learning roles. If you're like, no, I don't want to do all the stats, linear algebra, all of that stuff, I'm better off focusing just on programming data structures algorithms, SDE roles are more appropriate for you. Cool. So Shubham has a good question. So do you suggest first learn data structures and then programming, or do you want to first learn programming and data structures? Obviously, first learn programming in a good programming language, then go for data structures algorithms. This is a logical order. Don't do it the other way, because then you're learning some theory without ever solving problems. Okay, this is a better model, always. Okay. So again, another question here is, he has 5 years of experience as in Python programming, in Python automation, I think using Selenium scripts and things like that, if I'm not wrong. And he has theoretical knowledge of data structures. Okay, my suggestion is pick up 200 to 300 problems, improve your data structures and algorithms, and you can consider good roles, if not in top product-based companies, but surely in good product-based companies, right? So because you have 5 years experience, people with more experience, the bar also increases. Okay, but you can certainly go to good startups, right? So again, you can build on top of your Python automation experience, and you can join in something like an SDET role, SDE testing role. Okay, the compensation of SDET is very similar to SDE. Don't worry about it. Okay, just that people who have worked in Python automation type roles would benefit going to SDET roles. Right? The bar for data structures algorithms very similar to SDE roles. If you know theoretical stuff, practice. There is no other shortcut there. Okay. So, okay, Shavik Ghosh, he has a question. He says, I'm 25 years old. I'm sorry. I thought you had 25 years experience. I'm sorry. You're 25 years old, studying MTech in control systems. Okay, MTech in control systems. Okay, cool. Oh, very good. My final project is on biomedical signal processing and AI. Again, I'm assuming that given that you're asking a question about taking applied AI course, my recommendation to you is, I don't want to spend everyone's time here. Please go to applied AI course. If you're interested in applied AI course, the best place is, please go to this webpage. We have phone numbers, we have WhatsApp numbers and email addresses. Reach out there. Our team will help and clarify questions. They'll understand your background first, what your skills are, what is your gap, how much you know. Based on that, they'll recommend to you. Okay. In the interest of everyone, I would not be answering this question here. But yes, in short, if you're good in math, see, control systems requires a lot of math, right? So if you're good in the math required for control systems, and if you're strong in the mathematical parts of control systems, for you picking up AI will be very easy. Okay. Of course, you have to pick up programming and the relevant data structures and algorithms for AI, which will be slightly harder, but the math part will make it easier for you. So it's all about how good you are in the math. So please call us and we can help you there. Cool. Trojan has a very good question. I have answered this question in other systems also. So he says, let's assume I have a choice. Suppose I have a software development engineer one role at, let's assume, at a top product based company like Amazon, Microsoft, etc. Versus I can go and pursue an MTech. Let's assume at IIT Bombay or IISc. Which one should I choose? Okay, simple answer. If you want to go for a PhD, join this. If your objective is to go do a PhD later, please go here. If your objective is to work in the industry, this is a better option. Simple logic. Very simple logic. Okay, no shortcuts, because the 2 years that you spend in your MTech, in those 2 years, if you work hard at Amazon, you can become software development engineer too. So why spend time pursuing your MTech when you can go from SDE1 to SDE2? Simple logic. But if you want to pursue a PhD, then surely please go to these places, because from these places, it will open doors to top universities across the world for a PhD program. Very simple choice. If your objective is job, please go join the top product based company. No shortcuts there. So, okay, cool. So for ML and AI, do we need to be strong in math concepts such as stats and probability? Yes. If you're going for an interview, this is a question from Tushar and also from Nitin. So for machine learning and data science, you have to be strong at the foundational math. Okay. So you have to, if you're going for an interview, expect questions from statistics, expect questions from linear algebra, from optimization, etc. It is there. So in our course videos, what we have done, in our applied AI course, what we have done is we have covered most of these concepts from scratch. We only assume that you have studied maths in 11th and 12th class. If you have studied maths in 11th and 12th class, again, even concepts in calculus, we explain from first principles. Because we know that most of you, again, if you have not been using linear algebra, statistics, calculus, for the last few years, you will forget this. So we introduce all these concepts from scratch. But so if you're interested in a career in machine learning data science, we cover everything that is needed in the course videos of the applied AI course, right? But you should have an interest in it. So if you want to, if you're not sure whether you have interest in it or not, just go to applied AI course. We have lots of free videos, lots of publicly available live sessions like this one in our course also. Just check out some of them. If you're enjoying the math and if you're following the math, cool. You can certainly pick it up. You just have to continuously work. That's it. But if you're interviewing directly for machine learning and data science roles, please be prepared for the foundational maths in statistics, linear algebra, etc. Okay, folks, I think I've overshot by a few minutes. Thank you very much. And I know that in a public live session, it's almost impossible to answer all the questions. So anything that I could not answer, please feel free to go to Applied AI course. If your questions are about AI, go to Applied AI course. We have an email address. Please send your questions there. We'll try to answer as many as possible. If your questions are about software development engineer roles, please go to interview prep. Please go to interviewprep.appliedcourse.com, right? .appliedcourse.com. We have an email address there also. Please send any questions related to software development engineer, data structures, algorithms questions to this, and our team will clarify it. Anything related to data science, machine learning, AI, please send it here and our team will try and respond back as soon as we can. Again, please understand that it's impossible to answer every question in a public session. We try to randomly pick questions and answer as many as we can. Okay, thank you very much. And for all the applied AI course students, we have a live session tomorrow at 7 p.m. Tomorrow, I mean Sunday. It's a private live session. So please join that. Thank you very much. Bye-bye, folks.